Okay, we are here at lesson 4 where we talk about percent increase and decrease. So the opening exercise on your lesson worksheet, Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box, sketch Cassandra's 5 rings. So pause the video and sketch out some rings. Don't take too much time with this because you got plenty of work to do in the meantime. Alright, so hopefully you sketched out some rings. They could look something like this. So for part B, draw a double number line diagram relating the number of rings as a percent of the whole set of rings. So we have 5 rings, and if that's the whole thing, then that's going to be 100%. So a double number line would look something like this. The top line could be the percent, and that is going to equal 5. So 100% is going to be 5. How could we split that up? Well, then 4 rings would probably be 80%, 3 rings would be 60, 2 rings would be 40, 1 ring would be 20. So what percent is represented by the whole collection of rings? What percent of the collection does each ring represent? Well, the whole collection is 100%, and if you look at those lines that line up for each ring, then each corresponding ring is 20%. So how did you arrive at your answer for the opening exercise for part C? Well, we knew that there were 5 rings. We knew that the 5 rings represented the whole, or 100%. So we divided 100% and the total number of rings into 5 pieces on each number line. Each piece, or ring, represents 20%. All right, let's take a look at example 1. Let's look at some additional information related to Cassandra's ring collection. So Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? Well, looking back at our answers to the opening exercise, what percent is represented by 1 ring? If Cassandra gets the ring for her birthday, by what percent did her ring collection increase? Well, if 20% represents 1 ring, so her ring collection would increase by 20%. So compare the number of new rings to the original total. So 1 out of 5 rings is the same as 20 out of 100%, which is 20 hundredths, or 20%. Use an algebraic equation to model this situation. The quantity is represented by the number of new rings. So go ahead and write this down. Quantity is equal to percent times whole. We're going to let P represent the unknown percent. So 1 ring is equal to what percent of 5 rings? Well, to isolate P, if we're multiplying by 5, then we would end up dividing both sides by 5, so P is equal to 1/5. Well, 1/5 converted to a decimal is 20 over 100, or 20 hundredths, or 2/10, or 20%. All right, complete the exercises for exercise 1, then continue the video to check your answers. All right, you should be done with exercise 1. Go ahead and pause the video, check your answers and your work, and again, make sure you fill in anything that you missed, and if something doesn't make sense, make a note of it on your lesson worksheet and bring it to class. All right, let's go ahead and discuss what we've done so far in your journal. Remember, take notes only as you need to for information that you think you're going to need in the future. So what is an example of a situation that involves a percent decrease? Well, consider the following statement. A sales representative is taking 10% off your bill as an apology for any inconveniences. Write down what you think this statement implies. pause the video and then start it again when you are done. All right, here are some examples. I will only pay 90% of my bill, and 10% of my bill will be subtracted from the original total. So how does this example differ from the percent increase problems? Well, in percent increase problems, the final value or quantity is greater than the original value or quantity. Therefore, it is greater than 100% of the original value or quantity. In this problem, the final value is less than the original value or quantity. Therefore, it is less than 100% of the original value or quantity. Let's examine these statements more closely. What will they look like in equation form? Well, if we take the first one, I will only pay 90% of my bill, or the other one, 10% of my bill will be subtracted from the original total. Well, if you're only paying 90% of the bill, then the new bill is part of the original bill, so the original bill is the whole. So the new bill is going to be equal to 90% or 0.9% of the original bill. If we take 10% subtracted from the original, so the new bill is part of the original bill left over after 10% has been removed, so the original bill is the whole. So this means that the new bill is going to be the original bill minus 1/10 or 10% of the original bill. These expressions are equivalent. Can you show and explain why? Here is a hint. One example is if you are not paying 10% of your total 100% bill, what percent are you paying? Well, let N represent the amount of money due on the new bill, and let B represent the amount of money due on the original bill. So new bill is equal to the original bill minus 1/10 of the original bill. The new bill is 1B, because a B means 1B, that's the multiplicative identity property of 1. And now we can factor out a B from each term because we're using distributive property. So it'd be B times the quantity of 1 minus 1/10. And that means it would be B times 9/10. Or, because we can use any order, commutative property of multiplication, we would typically write it as 9/10 times B. So the new bill is 90% of the original bill. All right, let's take a look at example 2. Ken said that he is going to reduce the number of calories that he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by 7%? Justify your answer. So what are some examples of the words increase and decrease in real-world situations? Create 2 lists of words, one listing synonyms for increase and one listing synonyms for decrease. Okay, let's see how your list compares to mine. And if you need to include these, please go ahead and do this. This would be an important table to put in your math journal. So increase, there's several words. You have up, positive, debit, deposit, above, over, or add. And for decrease, some words are down, negative, credit, withdraw, below, under, or subtract. Using mental math and estimation, was Ken's estimate close? Why or why not? Well, you should have said no. 10% of 2,500 is 250, and 5% of 2,500 is 125. because 5% is half of 10%. So mentally, Ken should have reduced his calorie intake between 125 and 250 calories per day. But he reduced his calorie intake by 300 calories per day. Well, 300 is definitely greater than 250, which is more than 10% decrease. Therefore, it is greater than a 7% decrease. How can we use an equation to determine whether Ken made a 7% decrease in his daily calories? Well, we can use the equation quantity equals percent times whole and substitute the values into the equation to see if it is a true statement. So Ken reduced his daily calorie intake by 300 calories. Does 7% of 2,500 calories equal 300 calories? Notice how we change our equal sign to an equal sign with a question mark on it, because we're trying to check to see if this is a true statement. So if 300 is the quantity, and the percent is 7%, which we'll write as 7 over 100, and the whole is 2,500, then 300, is it equal to 7 hundredths times 2,500? Well, when you do that, you get 175, and is that equal to 300? The answer is false, because 300 is not equal to 175. And for part B, a 7% decrease means Ken would get 93% of his normal daily calorie intake, since 100% minus 7% is 93%. Ken consumed 2,200 calories, so does 93% of 2,500 equal 2,200? So let's check that. So if the quantity is 2,200, we want to know if that is 93% of 2,500. 93, and you can see where we divided by 100, 2,500 divided by 100 is 25, and 93 divided by 100 is 93. So 93 times 25 is 2,325, which means it is not equal, so this is a false statement. Therefore, Ken's estimation is wrong. All right, let's take a look at exercise 2. Complete the exercises, then continue the video to check your answers. All right, you should be done with exercise 2. So this involves Skylar answering the following math problem. Again, you need to identify the final value of the investment. Since we don't know that, we're going to call it capital F, or you could call it whatever you want. The final value is 90% of the original investment, since 100% minus 10% equals 90%. So if we're looking for the quantity is equal to the percent times the whole, then that would be 90% of 75, or 67.5. So the final value of the investment is $67.50. Okay, go ahead and read the answer. Again, make any edits that you need to, and if there's something that doesn't make sense, make a note and bring it to class. All right, let's talk about Skylar's thought process on this problem. Skylar's approach to finding the value of a $75 investment after a 10% decline was to find 10% of 75 and then subtract it from 75. He generalized this process and created a table of values to model a 10% decline in the value of an investment. Did his table of values represent his thought process? Why or why not? Well, the table only demonstrates the first part of Skylar's process. The values in the Y column are 10% of the original value, so Skylar would have to subtract in order to get the correct values. All right, let's take a look at example 3. We understand from earlier lessons how to convert a fraction to a percent. A common error in finding a percent increase or decrease, given the before and after amounts, is that we do not correctly identify the quantity or part and the whole or the original amount. Example 3 may reveal some misunderstandings related to this common error, which will allow us to pinpoint misconceptions and correct them early on. So Justin earned 8 badges in Scouts as of the Scoutmaster's last report. Justin wants to complete 2 more badges, so he will have a total of 10 badges earned before the Scoutmaster's next report. So if Justin completes the additional 2 badges, what will be the percent increase in badges? Again, our quantity is 2 badges, and our whole is out of the 8 badges. So he's already got 8, and he wants 2 more. In this case, we're not referencing the 10 badges total. So we want to know how many more than 8, and what's that percent going to be. So using quantity is equal to percent times whole, and letting p represent the unknown percent, it would be 2 is equal to p times 8. And then again, to isolate p, we can multiply by the reciprocal, which is 1/8. So 2 times 1/8 is 2/8, which is 1/4, which is also 25/100, or 25%. So there would be a 25% increase in the number of badges. So part B, express the 10 badges as a percent of the 8 badges. So 8 badges is the whole. We want to compare 10 badges to 8 badges. So 10 is the part, or the quantity, and 8 is the whole. So 2 badges represents 25% of the badges. So 10 badges represent 100% plus 25%, which is 125% of the 8 badges. And you can check that. So if 10 is our part and 8 is our whole, then we would have p times 8, and we want to isolate p by multiplying by the reciprocal, 1/8. So 10 times 1/8 is 10/8, or 5/4. Or if we turn that into a power of 10, it would be 125/100, which is the same as 125%. Does 100% plus your answer in part A equal your answer in part B? Why or why not? So yes, the answer makes sense because 8 badges are the whole, or 100%, and 2 badges represent 25% of the badges. So 10 badges would represent 100% plus 25%, or 125% of the 8 badges. All right, example 4. The population of cats in a rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? So, do we know the part, or do we know the whole? Well, we know the part, or how many cats are left, but we do not know the original whole. Is this a percent increase or decrease problem, and how do you know? Well, percent decrease, because the word declined means decrease. So if there is about a 30% decline in the cat population, then what percent of cats remain? Well, if we have a decline, then we can look at it as 100% minus 30% is 70%, so about 70% of the cats are still around. So how do we write an equation to model this situation? Well, 12 cats represent the quantity that is about 70% of the original amount of cats. We are trying to find the whole, which equals the original number of cats. So using quantity equals percent times whole, and substituting the known values into the equation, we have 12 equals 70% of W, where W is going to represent the original number of cats. So 12 is equal to 7/10, because 70 over 100 can be reduced to 7/10, times W. In order to isolate W, we can multiply by the reciprocal, which is 10 over 7. So 12 times 10/7 is equal to 120 over 7, which isolates W because this equals 1. So 120 divided by 7 is approximately 17.1, and so that's approximately 17 cats. So there must have been about 17 cats originally. So let's relate our algebraic work to a visual model. So here we have our 100%, And we have split it into tens, 10, 20, 30, 40, 50, 60, 70 to represent 70%. Well, if we have 12, then this would be 12 divided by 7, because the 7 comes from the 7 partitions between 0 and 100. So 12 divided by 7, 12 divided by 7. Each one of these represents 12 divided by 7. So 70% of the whole equals 12. So that's why this is equal to 12, and because it's partitioned into 7 parts, each one of these parts is 12 divided by 7, or 12 sevenths. So what is the quantity represented by 100 cats? Well, to find the original amount of cats, or the 100% whole, we need to add 3 more 12 sevenths to 12. So 12 is our part, okay? And now we're going to add, we have 3 more blocks to get to 100. Well, if each one of these is 12 sevenths, then we have 3 of those. Well, 3 times 12 sevenths is 84 sevenths plus 36 sevenths, because 84 sevenths is 12, and 36 sevenths is 3 times 12 sevenths. So that's going to be, when you add those together, 120 over 7, or again, approximately 17. So the decrease was given as approximately 30%, so there must have been about 17 cats originally. All right, example 5. Lou's math score on her achievement test in 7th grade was 650. Her math teacher told her that her test level went up by 25% from her 6th grade test score level. What was Lou's test score level in 6th grade? Does this represent a percent increase or decrease, and how do you know? Well, percent increase because the word up means increase. So using the equation quantity equals percent times whole, what information do we know? Well, we know Lou's test score level in 7th grade after the change, which is the quantity, and we know the percent. But we do not know her whole, which is her test score level from 6th grade. So if Lou's 6th grade test score level represents the whole, then what percent represents the 7th grade level? Well, it would be 100% plus 25%, so it would be 125%. So how do we write an equation to model this situation? Let W represent Lou's test score in the 6th grade, which is the whole. So quantity equals percent times whole. That means 650 is equal to 125% times W. In order to work with 125%, we can write that as 125 over 100, or 1 and 25 hundredths. Again, to isolate W, we multiply by the reciprocal. So we're going to multiply 650 times 1 over 1 and 25 hundredths. When we do that, we can get rid of the percent by multiplying by 100. That means 650 becomes 65,000, and 1 and 25 hundredths can become 125. When we do that, then that means that we will have 520 for our W. So Lou's 6th grade test score level was 520. All right, let's wrap this up. How does the context of a problem determine whether there is percent increase or decrease? We can look for keywords in the problem to determine if there is a percent increase or a percent decrease. Using the equation quantity equals percent times whole, what does the whole represent in a percent increase or decrease problem? What does the quantity represent? Well, the whole represents the original amount, and the quantity represents the amount of change, or the amount after the change. So for each of these phrases, identify the whole unit. You might want to stop the video and in your math journal create a table, a T-chart, so you can do this. All right, so you have phrase and the whole unit, which represents 100%. Here is the first phrase. Mary has 20% more than John. So what is the whole unit? Well, the whole unit would be John's money. Anne has 15% less money than John. Again, what is the whole unit? What is representing 100%? And that would be John's money again. What percent more money does Anne have than Bill? So in this phrase, what is the whole unit? Well, it would be Bill's money, because we're comparing Anne to Bill. And last, what percent less money does Bill have than Anne? What is the whole unit now? It would be Anne's money, because Bill is being compared to Anne. Bill would be the quantity, Anne would be the total. All right, we'll see you in class.